The wool moves through several operations as the blending process takes place. Bales are selected in line with the final product blend. The bales are then opened and weighed out into the correct quantities. Different wool types are placed around the feed point and checked prior to blending. Armfuls of wool are fed into the feed point in the correct proportions, alternating between the different wool fibres to start the mixing process. Pneumatic conveying equipment, including fans, pipe switches, condensers, and straight or elbow tubes, move the wool from one operation to the next. The Hainsworth picker machine, with its large metal teeth, is then used to open the fibre staples, separate the fibres, and remove loose dirt and contaminants. The wool is then taken to mixing chambers with travelling cyclones to layer the fibres one layer on top of another. A system of double binning is used to ensure good mixing. Vertical top-to-bottom cuts are made when removing material from one mixing chamber for passage to another. This process of taking vertical cuts and layering horizontally is important for mixing and can be done manually using a pitchfork. The fibre mix or blend is then usually moved pneumatically through pipes and ducts back to the Hainsworth picker. The Hainsworth picker machine is similar to the carding machine, however the teeth are much bigger. The wool is then moved pneumatically to a baling or storage bin in preparation for the carding process. At the input, the wool carding machine consists of a feed hopper. The wool is collected from the baling bin following blending and placed into the hopper. Following blending, the carding process begins by transferring the wool to a feed hopper from the baling bin. A weighing or metering device ensures a regular and consistent fibre feed into and through the machine. The first part of the machine, the scribbler, consists of a series of large rollers called swifts. Each of these has a series of smaller rollers called workers and strippers in pairs around their upper circumference. Every roller is covered with fine card clothing or card wire, which resembles protruding angled wire pins. Different roller pin directions and surface speeds are used to control, work and align the fibres as they pass through the machine. The two sections are separated by an intermediate stage, sometimes called a scotch feed, which removes a rope or sliver of fibres from the scribbler part and lays it across the feed sheet of the carder part. This means that the fibres are laid at a 90-degree angle across the carder part compared with their alignment as they leave the scribbler. This is an important fibre mixing feature of a wool carding machine. The fibres are then moved through the carder part of the machine. This has a similar roller setup to the scribbler. As the fibres are passed through a carding machine, fibre opening and alignment becomes more precise due to the card wire becoming progressively finer toward the output end. An even and regular web of fibres is removed from the last doffer roller, which is then passed through the final part of the machine called the condenser. The tape section of the condenser uses a series of flexible narrow tapes to separate the fibre web into narrow parallel strips. The tapes travel around rollers and convey the strips of fibre to the rubbing section, which rubs the strips into a round form. The rounded fibre strips are called slubbing, and these are then guided to the creel, where they are wound side by side onto condenser bobbins. Spinning is a single operation to convert the slubbing produced by carding into a yarn with a specified degree of fineness and amount of twist. The most common yarn spinning machine is the ring frame. During the spinning process, the full condenser bobbins are loaded onto the top of the ring spinning frame. They rotate so that the slubbing threads are continuously removed and pass individually through yarn guides. The slubbing threads then pass through a draft zone where stretching occurs. Two pairs of rollers are used. The front rollers travel faster than the back rollers, and the slubbing threads are therefore stretched. The degree of draft can be adjusted to give the required yarn thickness. After drafting, the yarn then passes through a yarn guide and is wound onto a tube positioned on a rotating spindle. Yarn is guided onto the tube by a metal or nylon traveller, which travels freely around the metal ring. The ring and traveller traverse up and down the tube on the ring rail. The tube and spindle revolve at an adjustable but predetermined speed. After spinning or twisting, the purpose of winding is to transfer the warp and weft yarn from the spinning tube onto alternative yarn packages, which are capable of holding a longer length of yarn. Electronic sensors called clearers can be used to detect thick or thin yarn faults. When faults are detected, they are removed and the yarn is spliced together again. The two ends of yarn are overlapped and held in a specially shaped chamber. A turbulent blast of air is then used to intermesh and entangle the fibres before winding continues. A guide distributes the yarn onto an appropriately sized package or cone. Tensioning devices regulate the firmness of the package. When completed, the cones are then removed and taken to the creels on the warping mill machines. Warping involves the winding of the warp yarns, called ends, onto a large cylinder called a warping mill. There must be the required number of warp ends, and these must be arranged in the correct order for the weaving of the Hudson Bay point blanket. Each section of warp thread is wound onto the cylinder alongside the previous section. It is necessary to traverse the creel sideways after each section until all the sections of yarn are on the cylinder. The cylinder has an inclined ramp so that the warp threads do not collapse over each other as they are wound on. A meter counter is attached to stop the cylinder when the correct length of each section has been wound on. A lease thread is then inserted, which can be identified in later processing. The warper cuts the threads and ties the ends so the sections will not unwind. The yarn cones are placed on yarn package holders in the creel in the correct colour sequence and are precision wound onto the warping mill. The completed warp is removed from the warping mill and wound onto a suitable weaver's beam at the back of the warping mill. The threads are fastened to the beam and it is rotated slowly so that the threads are wound on evenly. The beam can be stored until required and then transferred into the weaving machine, ready for weaving. Before weaving can commence, looming is the term given to the drawing of individual warp ends through the heel shafts and the reed. The ends are drawn through wire eyelets in the heel shafts in a specific order to suit the required design. This is called the draft. If it is exactly the same woven construction as previously produced on the loom, then a new warp can be knotted to the old warp, either manually or by machine, and looming can be avoided. The weft yarns are set up for weaving. On newer looms, computers are used to bring in the coloured weft yarn when required to weave the distinctive stripes. The short indigo points are also woven on the loom using thicker yarn. During the weaving process, interlacing of the warp ends and the weft picks takes place. Timing is important, and all the loom motions must be carefully sequenced to ensure satisfactory weaving takes place. Picks per inch are checked using a pick clock. The Hudson Bay point blanket stripes are measured to ensure the quality and consistency of the blanket. After scouring, milling is the next wet finishing process carried out on the Hudson Bay point blanket. The ends of the piece are sewn together and the cloth is conveyed through rollers. The top roller is weighted, and the constant passage through this roller arrangement in a moist state creates heat in the fabric. This combination of moisture, heat and agitation promotes fibre movement and felting, leading to consolidation and shrinkage of the fabric. Skill and judgment are required to control the process and to ensure the desired amount of felting is imparted to the fabric, and that excessive felting and shrinkage is avoided. A hydro-extractor machine resembles a huge spin dryer. The Hudson Bay point blanket is fed into a large circular stainless steel drum, which is designed to rotate at high speed. The drum is perforated so that water is removed from the fabric by centrifugal force and extracted through the perforations. Tentering then takes place to dry and tension the blanket. This means that fabric width can be controlled and any width variation can be evened out. The fabric pieces are fed into the machine and clips or pins hold the fabric edges. These are carried on chains at each side and are used to convey the fabric through the machine. Heating elements and fans are used to circulate the hot drying air within the machine, and extractor fans are used to expel the moisture-laden air. Following drying, the blanket then has a final inspection, which is carried out on a perch. The blanket is run over a vertical translucent plate and illuminated from face and back. The lines are checked for straightness, colours and overall quality. Raising is normally carried out by the passage of fabric over a machine roller, with many small revolving rollers around its perimeter. Each roller is covered by pinned card wire, or card clothing, similar to that used on a carding machine. The flexible wire pins exert a plucking action on the fabric to raise a pile on the surface. Fabric pieces require several passages through the raising machine to create a pile of the required height. Skill and experience are required in creating the correct pile by adjusting the speed of the drums at the front and back, the cloth tension, and the height of the wire rollers, as well as the number of times the blanket is passed through the raising machine. The Hudson Bay blanket's points are then brushed by hand, and the blankets are made up into the correct lengths by measuring and tearing them. Labels are then attached, and the blankets are packaged, ready for distribution to the Hudson Bay Company.